Hello, my name is Dr. Harriette Stone. I am the lead author of the chapter on technologies in the Global Infrastructure Resilience Report 2025 by the Coalition for Disaster Resilient Infrastructure, or the CDRI. This learning video focuses on technologies, harnessing the full potential. So, what will you learn during this learning module? We first will examine how technology can be used or implemented or adopted to improve the resilience of infrastructure. We will then look at how we move from the possibility that technology brings us to the reality, how we can move towards successful implementation and adoption of these technologies. The presentation will work through the following agenda. When looking at how technology can improve the resilience of infrastructure, we will explore the opportunities that technology gives us in our pursuit of resilience. We will look at the contributing ecosystem that will be required to join together in this pursuit. We will look at the ways in which technology can be used to increase resilience and look forward to future and emerging opportunities. And we will also explore some of the challenges and limitations. Second, we will look at how we move from what could be, or the possibility, towards successful implementation. The key elements of a strong enabling environment will be presented, as well as a readiness assessment checklist that will help organizations and stakeholders to assess how ready and equipped they are to successfully implement technological solutions to increase infrastructure resilience. There are 8 key messages that the report and this learning module will underline. The first is that technology is poised to radically transform resilience in infrastructure. Resilience through technology can be built by improving the data value chain, connectivity and communication, or by strengthening performance of assets or networks. There is also a strong financial case for using technology to build resilient infrastructure. Alongside this, an ecosystem of adaptive stakeholders is required to successfully harness the benefits of technology, including organizations that adapt and grow. And there is also a critical role for the private sector. And finally, to build resilience, high technologies or high tech is not the only option. Low tech solutions can also deliver transformative resilience benefits. But first, a little on scope and definitions. This learning module will consider the full spectrum of technologies, including both digital and analog, to search for good examples or potential opportunities for them to support the resilience of infrastructure systems, assets, and users. In this learning module, we define technology as the practical application of knowledge to solve problems or achieve goals more effectively. And below there are some specific definitions of different types of technologies that are considered in the report and in the learning module. We frame the technology chapter using this framework that runs through the whole of the Global Infrastructure Report 2025. We explore how technology can improve the capacity to absorb the shock of a disaster. We will look at how technology can increase the capacity to respond to a disaster. And finally, we dig into how technologies can support the capacity to recover. If we can do these 3 things better, we have increased our resilience. Resilient infrastructure is critical for sustainable development and economic growth, yet remains highly vulnerable in some parts of the world. And the challenge is huge. The Global Infrastructure Risk Modeling and Resilience Index, or GIRI, estimates annual average losses to infrastructure, including buildings, of $700 billion a year, and this is increasing. Meanwhile, modern infrastructure is becoming increasingly complex and interconnected, amplifying vulnerabilities and risks if they aren't built resiliently. The power shutdowns in Spain in April and May 2025 are a good example of the ripple effects of interconnected infrastructure systems impacting the whole of society. And all the while, innovations in technology race ahead. Within this context, there are many and increasing opportunities where technology can strengthen infrastructure's capacity to absorb, to respond to, and to recover from disasters. In addition, using technology can make financial sense. with the realised financial benefits of resilience, such as lower life cycle costs, improved performance of infrastructure, and even lower insurance premiums. A recent study on artificial intelligence, or AI, by Deloitte estimates that AI alone could avoid approximately $70 billion in annual losses to infrastructure. That's 10% of the annual average loss calculated by GIRI. Savings can be made in many different ways, including using technology for automated inspections, which has been done in the UK for one critical bridge and saved an estimated £1 million, whilst improving speed and safety to life too. And remember, as innovation continues, more opportunities will be created. Building resilience using technology requires an ecosystem of stakeholders. Technology and data providers are key, as they will innovate and develop solutions and produce the data that drives the technology use. Central authorities who set national or regional policies need to create a strong enabling environment that encourages, incentivizes, and rewards innovation and technology use across the ecosystem. The specific infrastructure owners and operators are the group that will actually implement the technology, and the end users or dependents are those that will benefit from the improved infrastructure resilience and can give user feedback to make further improvements. So what are the ways that technology can be used to increase resilience in infrastructure systems, assets, and users? The first category is improving the data value chain, which includes improving data collection, data processing, and decision support to improve the capacity to absorb, respond, and recover. The listed technologies can contribute to this. The second way technology can build resilience is by improving connectivity, communication, and collaboration. Technology can achieve this through digital collaboration tools, effective alert systems, and targeted communication. Technology such as virtual reality, AI, social media platforms, satellites, etc. can support this. The third pathway that technology can support to improve infrastructure resilience is by strengthening asset and network performance, which can be achieved by using innovative construction materials or methodologies such as 3D printing, as well as employing technology to improve asset performance, increase redundancy in systems, for example using battery storage, and strengthen operations and maintenance. We will dig into more examples later in the learning module. I talked earlier about the framing of resilience as the capacity to absorb, respond to, and recover from disasters. I also think that it's important to map this to the infrastructure life cycle, with which many infrastructure professionals and stakeholders may be more familiar. The three core functions of technology just discussed of improving the data value chain, improving connectivity, communication, and collaboration, and strengthening asset and network performance support increased resilience throughout the infrastructure cycle and the absorb, respond, recover framework. We will explore more on this in detail now. Technology can give a better understanding of the risks faced, improve design and construction practices and capabilities, and advance proactive advice for decision makers and users. This will all lead to improvements to preparedness, operations and maintenance, strategic decision making, user preparation, new infrastructure being built or retrofitted, and early warning systems and early action systems, which all in turn increase resilience to strengthening the capacity to absorb shocks. And here are some case studies of technology helping to strengthen the capacity to absorb. Google has used AI and satellites to build exposure databases to improve risk modeling and post-disaster analyses. The new Bullard Spa Dam in California is using digital twins, drones, Internet of Things sensors, and other sources of data to collect and process in order to support operations and maintenance. The Credo Plus initiative in the UK is using models to replicate complex interconnected infrastructure systems to stress test them and identify vulnerable areas for investment and improvement. 3D printing is also being used for building more resilient homes with precision and accuracy. And finally, in India, an NGO called Seeds is using AI to tailor early warnings by the type of structure that you live in and where you live to ensure that households receive the most relevant and actionable advice. During the response phase after a disaster, technology can help authorities and stakeholders gain a faster and more accurate understanding of the type, scale, and distribution of impacts, and enable faster and more effective decision-making in the deployment of technical assets and expertise. It can help inform the performance of infrastructure services so that users can be more resilient, as well as provide faster and more accountable finance for response activities. All of this is achieved by using technology to monitor performance and status in real time, to share data quickly between stakeholders, improve interagency coordination, and improve communication with impacted communities. An example where technology has been used to strengthen the capacity to respond to a disaster can be found in Brazil, where they created a multi-purpose dashboard where authorities at all levels could post their impact data. This supported decision makers and communities enormously after the floods in 2024 in Rio Grande do Sul. In the US, FireSat satellites are being used to track and monitor wildfires in real time, and the data collected supports the coordination efforts during the response phase. Blockchain technology, which enables transparent and accountable funding for recovery efforts, has been used in Vanuatu to support communities to rebuild. And finally, AI chatbots were used by the World Health Organization, or WHO, during the COVID-19 global pandemic to respond to questions, provide guidance, and support health responses across the world. And now we move to explore how technology helps in the recovery phase of a disaster. Technology can support the prioritization of repair and reconstruction activities using data and evidence. It can support the uptake of construction standards and resilience guidelines and the continued coordination of key stakeholders working during this phase. Financial technology such as blockchain and tailored communication with communities can also continue through this phase. A great example of technology in practice to improve construction and resilience during recovery is the use of mobile monitoring. After the 2015 earthquake in Nepal, this technology was employed to monitor construction and provide technical supervision and advice to remote parts of the country where experts could not physically be all the time. It reduced the need for frequent site visits while ensuring rigorous technical oversight. Now, having shared some examples of case studies, if we look forward, there are many future trends and emerging opportunities too. Global open datasets are rapidly expanding and improving through the use of technology to collect, improve, and share data. Tools like AI are starting to support resilient design processes while promoting transparency and accountability in the construction sector. And as computing power increases and becomes more efficient, technologies that strengthen resilience of infrastructure will become more powerful and impactful. VR, or virtual reality, is becoming a valuable tool and has many applications for increasing resilience, particularly for communication and collaboration purposes. Technology for communication and connectivity is also rapidly expanding. Low Earth orbit satellites, or LEO satellites, open up many opportunities. Hardware technology such as drones and sensors are also improving and have many applications across the infrastructure cycle. Innovations in materials and construction techniques and methods are supporting more resilient infrastructure assets. Improved computing power and speeds through quantum computing, edge computing, and cloud computing are all powerful technologies that can contribute to increasing resilience in future years. And finally, satellites are not only more numerous, but continue to offer higher resolution and higher frequency images. There are, of course, different types of challenges and limitations to the use of technology that also need to be considered. These can be grouped into these themes and are explored in detail in the report. The successful implementation of technology for resilient infrastructure requires an enabling environment that promotes, supports, and sustains the use of technology in those applications. The report presents 7 key elements or building blocks that make up a strong enabling environment. Strong governance and leadership is critical to driving the use of technology forward. Financial readiness and sustainability is critical to ensuring funding streams are in place to start and sustain technologies. And institutional and human capacity is required to be able to manage and use technology appropriately. Data is a critical element and needs strong rules and regulations around its collection, storage, sharing, and use. The culture of change and adaptation in an organization is critical to ensuring the success of innovations, and relatedly, having the processes and systems to monitor, evaluate, learn, and evolve is very important to ensuring technology's continued success. Finally, the ecosystem of partners and collaborations needs to be strong, functioning, and aligned to ensure that technology employed increases the resilience of infrastructure in the most effective and efficient ways. We will now dig a bit deeper into these key enabling environment building blocks. Strong governance and strategic leadership looks like the ability to mobilize resources, generate high-level support, and build coalitions around ideas and innovations. It means having clear, defined responsibilities and transparent decision-making processes. Clear national visions and strategies help to frame a clear space for stakeholders to operate within, and the associated policies and regulations are needed to ensure that technology adds value and does not increase risks. Money is obviously a really important building block to implementing technology to achieve resilience. Clear, functioning, predictable financial mechanisms that support or incentivize innovation and the adoption of technology are critical. Upfront costs can be substantial, but ongoing maintenance and operational costs can also be significant, and both types of funding are required. Institutional and human capacities are required to set up, operate, and interact with technological solutions, and this may require national-level skills strategies or frameworks to guide educational institutions to increase the level of skills at a national level. An environment that encourages collaborative learning and shared capacity development will also improve success rates for technology adoption. Data is a critical sibling to technology, and its governance is really important. Clear standards and regulations for data collection, storage, security, and use are needed, but further, having systems in place that make data interoperable between agencies and organizations will increase the impacts that technology will have. Zooming out, a wider investment in digital infrastructure, such as broadband, cloud services, and the like, would strengthen the enabling environment. Technology and innovation brings about a lot of change for organizations. Changes will come about to processes, systems, decision-making, and day-to-day jobs, and having a culture that is flexible and adaptive and that welcomes change and progress through innovation is a key building block to a strong enabling environment. In parallel, having an organization that is able to evaluate performance and learn and evolve quickly and efficiently is a strong building block for increasing resilience through the use of technology. Having monitoring systems that support learning activities, strong monitoring, evaluation, and learning frameworks, and centralized systems to share lessons and learnings can all contribute. And finally, there is a diverse set of actors who are interested in increasing resilience through technology. If that ecosystem can operate and work well together, the enabling environment will be much stronger. From researchers, inventors, and technology developers, through to users and beneficiaries, a whole ecosystem that works well together would be a strong environment for successful adoption of technology. But how can organizations assess how strong the 7 enabling environment elements are and what to focus on improving? To answer this question, a readiness assessment checklist has been designed and is presented in detail in the report. The checklist is a structured and action-oriented framework for evaluation to help you understand how ready you may be to adopt technology successfully with the aim of strengthening resilience of infrastructure. It can be used by ministries, agencies, and infrastructure operators to identify current strengths and weaknesses and build a plan for improvement. There are 2 sets of questions in the checklist, depending on the type of organization and their responsibilities. One set of questions is for those at a country or subnational level that oversee, such as ministries. And the second is for those that will actively implement the technologies, such as utilities or infrastructure agencies or private sector infrastructure operators. The checklist has 4 to 6 questions related to each of the 7 enabling environment elements, which help to assess the current state of readiness to successfully implement technology. The assessment is designed to be universal, flexible, and impact-oriented. It can be undertaken internally within individual organizations, or it can be outsourced to external persons to complete. But either way, it will benefit from participatory approaches and involvement of a wide range of people from within organizations. The checklist follows a 4-step process. First, the diagnosis using the questions. Areas that require strengthening can be prioritized and an action plan put in place. Monitoring of progress against these actions takes place over the agreed timelines, and reassessment can show the improvements made. Here's an example of a before score in the black, where there are some elements that are strong and some weak areas. The red area indicates the improvements that have been made when the assessment was carried out again. So, in summary, technology is set to radically transform how we build and maintain resilient infrastructure. This report and learning modules have highlighted 8 key messages. First, technology has the potential to significantly strengthen infrastructure resilience. It can do this by improving the data value chain, enhancing connectivity and communication, which improve collaboration, and strengthening the performance of infrastructure assets and networks. Second, there is a strong financial case for investing in technology to build resilient infrastructure. Successfully harnessing these benefits requires an ecosystem of adaptive stakeholders. This includes organizations that are able to learn, evolve, and collaborate effectively, with the private sector playing a particularly important role. And finally, building resilience does not always require high-tech solutions. Low-tech approaches can also deliver transformative resilience benefits. During this learning module, you have seen that technologies have the potential to enhance infrastructure resilience. We have also acknowledged persistent challenges, including governance gaps, financing constraints, limited skills, weak data systems, risks of exclusion, and environmental costs, all that must be addressed to ensure that technology delivers the intended benefits. We've emphasized the importance of building robust, enabling environments where governance, financing, institutional capacity, and inclusive approaches work together to support sustainable technology adoption. A 4-stage readiness assessment checklist has also been presented, which provides a practical pathway for countries to systematically harness technology for resilience rather than adopting solutions in an ad hoc manner. The findings of this working paper are incorporated into the Global Infrastructure Resilience 2025 report, where they are integrated with insights from the other work streams on finance, institutions, governance, and nature-based solutions. If you'd like to learn more about this topic or the others, please read the full report on CDRI's official website and the DRI Connect, CDRI's digital platform for professional collaboration, learning, and knowledge exchange on disaster-resilient infrastructure systems.